Hey y'all, I'm Sir Pinkbeard, and in my day job, I'm a senior software engineer at a Fortune 500 company. I also have been teaching people how to program in various different languages for at least the last 6 years. So I figured it was time to bring that skill set to YouTube and create a video series on how to program. So in this video series, I'm going to be showing you guys how to code and how to write good code in C#. Now, what can you expect from this series overall? So, right off the bat, you can expect that the series will assume that you know nothing about programming. I'm going to cover everything you need to know to get a really solid foundation of coding in C#, and we're going to do that in two ways. One, we're going to do it by adding in some lecture sections so that you can take some notes and actually understand and digest what I'm talking about, and then we're going to do some follow along where you're going to code. And overall, throughout the series, we're actually going to learn all of these topics, cover all of this information, and apply it by building a text-based RPG. And if that sounds interesting to you, then let's get started. In order to begin coding, you will need an IDE, an integrated development environment. An IDE allows you to edit code, build complicated projects, and provides tools to make building applications easier. While working in C#, there are really only 3 IDEs to choose from: VS Code, Visual Studio 2022, or whatever version happens to be out when you're watching this, and JetBrains Writer. So let's choose one and get started. Now, VS Code, or Visual Studio Code, is a perfectly good text editor, and it can do a lot of powerful things, but it doesn't come with much straight out of the box. So there's a lot of extra configuration that we would need to do in order for you to get set up and work with it. For this reason, I don't think that this is the right choice for a coding apprentice. You will likely use VS Code at some point if you stick to being a software developer, but in my day-to-day, this is just a fancy text editor that works for all coding types. And it's perhaps the best text editor for developers, but this is not the best coding IDE for C#.NET developers. Next, we have Visual Studio 2022. This is Microsoft's IDE, and it is the default choice for developers working with C# and any other Microsoft languages and C++. Now, it comes with a ton of tools straight out of the box that will be incredibly helpful for working with code. And it's actually the one we're going to use in this course because it's free for individuals, students, and people contributing to open source software. However, if you're on a team or working for a company, your company will probably need to purchase a license to use the professional or enterprise version, which depends on the company's size and maybe revenue. While Visual Studio is generally used on a Windows machine, there is a version for Mac OS, so if you're on a Mac and you want to learn to code in C#, go ahead and download that version. There's a link to this site down in the description below, so if you don't yet have Visual Studio installed, go ahead and pause this video, download Visual Studio 2022 or 2019 for Mac, and come back so then we can talk about Writer. So while you're downloading Visual Studio 2022, let's talk about JetBrains Writer. JetBrains is a company that creates really solid software tools, and if you're working in any modern language, JetBrains probably has an IDE that can handle and improve your work in that language. And Writer is their .NET IDE. So as you can see, you can work with all of the text shown in the bubbles, and we'll be using it for some other tutorials that I've got planned for in the future. Personally, I use JetBrains Writer to do most of my programming either at work or in my spare time because it has built-in tools for keeping my code clean and easy to read. There are also some additional tools that work just as good, if not better, than some of Visual Studio's tools. So if you subscribe to the channel, you're going to see a lot more of JetBrains Writer in the future, which may convince you to buy it for yourself. And the best part is that since they have a suite of tools, they are all similar enough that if I need to switch back and forth between languages like Java or SQL Server or front-end tech like HTML, CSS, and JavaScript, I don't have to learn a new IDE layout in order to work efficiently in that language. The downside of this is that they don't have a free version. They'll give you a 30-day trial, but after that you have to pay for a license, which does get cheaper the longer you pay for it. So if you're going to stick to programming and want a great set of tools for a bunch of different languages, I recommend you check out the JetBrains IDEs, and particularly Writer if you're going to work in C#. Now, I'm not affiliated with them at this time, I just think they're awesome. Anyway, your download for Visual Studio installer should be underway if not complete, and once the installer is finished, you should get a window like this. Now, Visual Studio offers you different workloads to install, and for this course, all you'll need is the .NET Desktop Development workload. I also have the ASP.NET Web Development and Unity workloads installed for game development, so if you plan on sticking around for future tutorials related to programming and game dev, go ahead and install those. Once Visual Studio is installed and you launch it, you should see a window similar to this. Now, you won't see any recent projects if you're just starting on it for the first time, but once you've worked on something, it'll show you what you've worked on recently. Now, go ahead and click Create a New Project, and we're going to create a new console application. So, up at the top, go ahead and change the language to C# because there are a few other languages in the .NET family that we don't want to choose from, and then search for console. You'll see some options to choose from: console app C#, console app VB, and console app C# .NET Framework. Let's ignore the VB option and allow me to explain a little bit about the differences between the console app and the .NET Framework version. .NET Framework is the old version of .NET, and while it's definitely still used to create new applications, mostly in corporate settings, Microsoft rewrote most of the .NET libraries to allow for use across platforms, creating something called .NET Core. I Am Tim Corley has an excellent video on this if you want to know more about it, but for our purposes, just know that the .NET Framework version is an older version of .NET that Microsoft is trying to move away from, so we won't be touching it at all in this series. Now go ahead and choose the C# console app option, and let's name the project. Now this project is going to teach you how to code, so you could call it Learn to Code, but as I said earlier, we're going to learn all of the coding elements by building a text-based adventure. So let's call this Dungeon Adventures with no spaces between them. Once you've named it, you can see that the solution name has changed to match the project name. This is the default behavior, but you can also change the solution name to something else if you'd like. You can also change the default location for where this code will be stored, but Visual Studio wants to put code in the source repos folder on your user profile. So make any changes that you want to, and then hit next. Now this is very important for this course. .NET 6 is a long-term supported version of .NET, but they changed how console applications are created in .NET 6, and I can't teach you all that you need to know using the new version. So let's change this back to .NET 5 and then hit Create. Visual Studio will create your new solution and project and then open up to give you a view like this. Now, depending on the theme you chose when you started up Visual Studio for the first time, your application may look different. But if you want to check out the other themes, you just have to go to Tools, Options, General, and then change the color theme. However, if you spend any amount of time coding, you'll probably end up in dark mode because it's easier on your eyes than staring at light mode all the time. Now before we go any further, let's finish our Visual Studio setup by downloading a single extension called Sonarlint. So go up to the top and click Extension and then Manage Extensions, and then search for Sonarlint. Then hit Download. Basically, this tool will read your code and make suggestions about how to improve your code or how to fix issues with readability. And if you listen to it, it will help improve your coding skills. Once you download it, you just have to close any and all instances of Visual Studio in order for the extension to install. Just follow the prompts on the screen, and then once it's done installing, reopen Visual Studio. Now that Sonarlint is installed and Visual Studio is open again, let's get familiar with Visual Studio and our solution so that we can get a solid cornerstone on which to build our foundation of coding knowledge. So right off the bat, we have the program.cs file open in the middle. We can see that Visual Studio also created some template code for this file when we created the project, which is what we can see in the file. And this is our code editor section. We'll write new code in different files here. Below our code editor, we have an error list window. This section will show us any errors or warnings that appear while we are coding. Currently, we have a warning in here from Sonarlint telling us to make a change to our class. We're going to ignore this one because it's for the program class, but we can also see the warning appear as a green squiggly line under the word program. Warnings will appear as green squiggly lines, and errors will appear as red squiggly lines. If I remove this semicolon, you can see a red line appears in that location, and the error appears in the error list below. The only other window that matters for now is the Solution Explorer window. This window shows you all of the projects and their files contained within the solution, and it's my opinion that this should remain as organized as possible to make maintaining the codebase as easy as possible. But since we're seeing our project structure here, let's take a moment and talk about the structure of a C# solution. A solution is nothing more than a container for holding projects, and it can have as many or as few projects as you need. But for it to be useful, you must have at least one project. It can have any name you want, and as you can see, our solution and project have the same name. But as I said earlier, it doesn't have to. So think of it like this. A solution is a large binder, and each project in that solution is a subject folder in the binder that groups related code together. Now, as I said, you can have as many projects in a solution as you need, but you want to make sure that they actually relate to each other. For example, you wouldn't put a cooking recipes folder in your school binder with the math, science, and histories folder. So don't put unrelated code inside the same solution. Moving on to our projects, we currently have a console application project, and if we select it, right-click and choose Properties, we can find out specific information about the project. Immediately we can see some general application information like the output type is a console application, but if we click that dropdown we could change it to be either a class library, which is a non-executable group of code that can be reused as needed, or a Windows application, which can take on many forms, but is meant for mostly GUI or long-running service applications. We can also see that it's targeting .NET 5 because that's what we chose when we created the application, but go ahead and change that to .NET 6 and then close out of this window. Now that we've learned the anatomy of a project structure, let's take a look at the anatomy of a class file real quick and then run our very first program. First off, on line 1, we have using system, which is known as a using directive, and it tells our code that inside the program class, we are going to use code found in another namespace or project. By having the using system directive, we can access the console class, which is contained inside the system library that is built in .NET. If we hover over console, you can see that class name is system.console, which tells us that the object's code resides in the system namespace. Let me pause here for a moment to let you know that .NET itself comes with a ton of different built-in libraries and namespaces, and you can access all of it through using new using directives. Next up, we have our own namespace in the program.cs class, Dungeon Adventures. A namespace simply tells us where our code resides. So we can see that the program.cs file exists in the Dungeon Adventures project, and so it exists in that namespace. If we had multiple projects in the solution, each project would have its own namespace corresponding to the name of the project. Next, we have our class section with internal class program. Ignore the internal keyword for now, we'll cover it a bit later in the series, and focus on the class keyword. A class is simply a container for code. There are many types of classes, which we'll get into later, but for now, you only need to know 3 things about them. 1. Classes are simply containers for code. 2. All classes have a name, as shown by this one called program. And 3. While it's not required, in the majority of cases, it is a best practice to have a single class per CS file in your Solution Explorer. Then we have methods, which we'll cover in depth later in the series. For now though, methods are a way to group code by a name to do a task. So we have a static void type method called main, and this is known as our main method. For a console application, the program will begin by executing the first line in the program.cs file's main method, and will end by executing the last line of code in that main method. And finally, we have code that will actually run, which is contained within the main method. The console.writeLine statement will be what executes when we run our application. So let's actually run our program by clicking on the Dungeon Adventures play button at the top, which immediately pops up a console window and executes our code. And then it displays some final closure information. The last line here says press any key to close, and if I hit my spacebar, you can see that the console shut down immediately. Congrats on running your first console application in C#. Before we move on, let's just recap about the anatomy of a class file. So if I were trying to explain this file to a non-programmer, I would say something like this. In the program.cs file, we have a class called program, which exists in the Dungeon Adventures namespace and uses the system library. The program class contains a single method called main, which writes a line of text containing hello world to the console. If that explanation makes sense to you, then you're ready to move on. If not, I'd suggest going back to the beginning of this section and then rewatching to really make sure you understand the anatomy of a class. Now that we've run our first program and you understand what the code is saying, we can actually work on our text-based adventure. So let's get started with our game. I'll delete this line of code and let's print something out to the console. To interact with our console, we just need to type console dot. Once we have the dot, a drop-down window will appear, offering us options for what we can type next. This is IntelliCode at work, which intelligently senses what you're typing and offers it what it thinks will be the best match for what you want to type. But I want to write out something to the console, so I'll type write, and IntelliSense will offer me write or writeLine. The difference between the two is that writeLine will write a whole line of text and then end the line with the enter key, whereas write will write a line of text and then not end the line. Let's see how that works in practice though. So I'll choose writeLine, and inside the parentheses let's type double quotes, because when you want to output a string of characters you need to signify that string with double quotes, and then inside those quotation marks I'll add a greeting. So we've added our greeting, but we still have this red squiggly line here. If we check the error message at the bottom, we can see that a semicolon is expected at the end of the line. Most of the code we write in C# will end with a semicolon, so get used to typing them. If we add a semicolon to the end of the statement, the error goes away and we can move on. If we hit enter and move on to the next line, Visual Studio suggests doing another console.writeLine. So I'll tab and accept that line and then ask the user a question. What is your name? Don't forget your semicolon, and then we need to prompt our user using console.write. So we'll add a console.write with a short message for what our user should do. Because console.write doesn't end the line, the user will be able to input their name on the same line as the prompt. But how do we get the program to pull in the information that the user types? We do that by using a console.read method. Now if you type console.read, you'll see IntelliSense provide us with a few options. Read, readLine, and a read key. The read method reads in the next character that is pressed. The read key method waits for the next character or function key that is pressed by the user. Neither of these options will work for us because we want the user to input a string of characters representing their character's name. To do that, we'll need the readLine method. This will let our users type in their full name, and then when they hit enter, the console will pull in the full name that they typed. So let's run the application and see how this works together. You can see we have two write lines, and the text is on a new line each time. Then our console.write prompt is on a line of its own. The cursor is also blinking on that line, showing us that we can input information on the same line. So if I add my name, I can type all of these characters, and then as soon as I hit enter, the console reads in my name and finishes executing because there's no more code to execute after the read line. It's important to know the flow of control in a console application goes from the top of the main method to the bottom of the main method. Since we have no lines of code after the readLine command, the console application realizes it's complete and stops running. Flow of control is something we'll talk about later in the video, but for now, all you need to know is that flow of control is the order that code commands will be executed in an application. So now that we've prompted the user and read in the name, what if we wanted to do something with the name that the user provides? Well, we'd need something called a variable to store the name that the user gave us for future use. So let's talk about variables. Now, like I said before, in order to use the name that the user inputs with the console.readLine, we'll need to store that name for use later. Maybe we'll have a cutscene where we'll need to address the player by their in-game name or something like that. As I said before, we'll use variables to store that name, and there are a bunch of different variables that we can use to store different types of data. Variables are broken down into two categories, known as primitive data types, which are also known as value types, and objects, which are also known as reference types. We'll talk about objects in a future video, so for now, let's get to know our primitive data types. C# is a strongly typed language, meaning that it has types of data built into it, and data can only be stored in their special container or type. So if we look at this chart here, you can kind of get a feel for what I mean. C# has many different variables for holding numbers, and those are broken down into subcategories for integer types and real numbers. And the integer types, which you see on your screen, are broken down further into signed and unsigned variables. The difference between them is that an unsigned integer can only hold positive numbers and 0, whereas a signed integer holds both positive and negative numbers. The main integer types are byte, short, int, and long, and they all hold a different range of numbers. The reason we have so many different integer types is because as a programmer, we need to be at least slightly concerned about the memory usage of our applications, and each type either uses a different amount of memory or uses their allotted memory in a different way. Let's take a look at the byte and S-byte types. We can see that a byte has a range of 0 to 255 and that it is an unsigned 8-bit integer. Without getting too deep into the hardware, just know that everything in programming eventually turns into binary. A single binary digit is called a bit, and a bit can only be a 0 or a 1, which means that a single bit can only represent 2 values. However, computers group bits into chunks of 8, which are called bytes. A single byte, or 8 bits, can represent up to 2 to the power of 8 values, which means that a single byte of memory can represent 256 values. The byte type is an unsigned 8-bit integer, meaning that it uses a single byte of memory and can only store positive numbers and 0, so the range it can store is 0 to 255. The S byte is also an 8-bit integer, but since it's signed, the possible values get split down the middle, giving us a range of -128 to +127. The rest of our variables behave the same way as the byte and S byte, but each one doubles the amount of memory than the previous one used. So the short and U short uses 2 bytes of memory to represent just over 65.5 thousand values, and the int and uint uses 4 bytes of memory to represent just under 4.3 billion values. The long and ulong use 8 bytes of memory to represent a truly ridiculous amount of values. The literals for each of these types is just the number they contain, and a literal is just what that value looks like when you write it in your code. So here's where the concern comes in. A single int uses 4 bytes to represent a number, which on its own isn't a big deal. But if you have 250 int variables active at a single time, you're now using a total of a single kilobyte of memory, which again isn't a big deal in today's world. After all, it takes roughly 1,000 kilobytes to be a megabyte and roughly 1,000 megabytes to be a gigabyte, and modern computers often have at least 8 gigabytes of RAM to work with. But if we don't want to end up with applications that eat RAM as much as Google Chrome does, then we should put at least a little thought into what we actually need to store when picking our variables. Now that we have an understanding of the integer types and why we have so many, let's talk about the other C# variable types. First off, we have the floating point types. Now, C# only has 3 floating point variables, which can be used to store real numbers with decimal places. They are float, double, and decimal. Each of them will have a different number of precision points after the decimal that they can be considered accurate to, and you can see those on your screen here. Now, when using floating points, C# will consider all real number literals as a double unless you put an F or an M at the end of the literal. Next, we have the bool type, which is a variable that can hold only true or false values, and you'd use them in scenarios when you need a flag to mark something, click a checkbox, or make decisions in your code. We'll talk about those a little bit later in this video, but their literals are just the true or false keyword. And finally, our last primitive type is known as the char type. This variable can hold either a single character or a hexadecimal Unicode escape sequence, and when you write it in code, its literal is contained within a single quotation mark. So that's it for the primitive type, but there's one other data type that can be considered an honorary primitive type, though it works much differently in the .NET architecture. That type is the string type. The string type is just a sequence of characters, and its literal is denoted by a double quotation mark. We've already written a few string literals in our program in the write and writeline statements, so you should have some familiarity with them. The one thing you need to know is that a string is immutable, meaning that once you've set the string either in a literal or just in a variable, it cannot be changed. C# may allow you to do things with string variables that look like you're changing the contents of a string, but what's actually happening is that the old string is being deleted and a new string is being created with whatever manipulations you've done to it. There are lots of other things you can do with strings, and we'll cover some of those later, but that's enough about the variable types. Let's get back to the code and actually use what we've just learned. Now that you understand the basics of variables, let's create our first one. To create a variable, you have to do 2 things: declare it and assign it a value. In our program, we are asking the user for their character's name, so we need a string variable to hold the string of characters that they will enter. To add our string variable, type the string keyword, and then we have to assign the variable a name, which in this case we can just use name. It's important to name your variables as descriptively as possible so that when you come back to your code later, it's much easier to read. Then I'll add a semicolon and we fully declared the variable. To assign it a value, on the next line we can write name equals console.writeLine. This will assign whatever the user inputs in the console to the name variable. Currently we are declaring and assigning a value in 2 steps, but C# allows us to do this in a single step. So if we change this line to string name equals console.readLine, and then delete the standalone declaration, we can now declare and assign our name variable in one line. Now that we've gotten some value in name, how do we access that information? Well, to access it, all we need to do is type the variable's name. So let's have our narrator confirm the name that the user entered. To do that, add a console.write prompt with a space at the end of the string literal, and then we'll just add in a console.write line. But this time we'll use the Visual Studio macro for it. So just type CW and then hit tab twice, and it creates the console.writeLine statement for you. That'll just save you some typing in the long run. And then put the name in parentheses. When we run our application, we can input our name, and then we'll get a response back with the name that we entered. So let's refactor or clean up this code and talk about some of the cool things that we can do with strings to help us write less code. Instead of using 2 calls to print the name, let's turn that into one WriteLine command to print the confirmation and name using something called string concatenation. Basically, string concatenation means that you can combine 2 or more strings by using the plus symbol, which means that I can type this and then add a plus symbol and the variable name, and when it gets printed to the console, the string literal and the value of name will be printed to the screen together. Now when you use the plus symbol for concatenation, the plus symbol simply adds the parts together. So if I create an int variable called number and set it to 0 and then concatenate that variable to the end of the write line, the 0 will just be added to the end of the name. In the grand scheme of things, concatenation is pretty slow. So if you have 100 strings to concatenate, you'd probably want to find a different method for adding them all together. But for a small handful of things, this works just fine. Now, while string concatenation works in many cases, I prefer the second of our string options called string interpolation. To interpolate a string, simply add a $sign to the beginning of the string literal. And then, wherever you want to add in a variable, you can simply add a pair of opening and closing squiggly braces to the inside of the string literal, and then call your variable from inside the squiggly braces. Interpolation is not only faster to write, but it's also easier to read, since you can see how the whole string will be created. If I run this, you can easily see that the name gets added, and the final question mark is added after the name I enter. If I wanted to get that question mark to appear while using concatenation, I'd have to split the string like this. Now, depending on your preference, both options will work just fine. However, I prefer interpolation, so that's what I'm going to be using for the rest of this series. So we've asked our player for their character's name, and we've added a prompt to ensure that they input their name correctly. But how do we have them confirm their choice? Obviously, we need to prompt them in some way, and since this is a console application, we'll need to provide options for what we're looking for in return. So I'm going to add a yes/no prompt and circle the Y and N so that they know what to type in their response. Next, we need to take in their response and store it. So let's create a new string variable and take in user input. And at this point, we can see Visual Studio offering me an if code statement. So let's hit tab to get that code segment, and then take a quick minute to cover all of the information you need to code decisions correctly. C# evaluates decisions based on something called Boolean Expressions. A Boolean expression is a logical statement that evaluates to either true or false. So think about it like this. Say you're trying to make a decision about whether or not you should take an umbrella with you to an event. You may say something like, if it's going to rain, then I should take my umbrella. The Boolean expression here is it is going to rain, because that is either true or false, and the logical outcome of that expression will decide whether or not you take the umbrella. In C#, that may look something like this. You can see we have a bool variable, is going to rain, that tells us whether or not it will rain later. Since a bool value is always true or false, they can act as a complete Boolean expression. Then we make the decision by using an if statement. If is going to rain is true, then we'll take the umbrella. This section inside the squiggly braces will only execute if is going to rain evaluates to true, because an if statement's Boolean expression must always be true in order for the code contained within the squiggly braces to be executed. We can also create custom Boolean expressions using C#'s comparison operators. C# has a few comparison operators, and they are as follows. Equal equals checks equality. This operator wants to know if the value of x and the value of y are equal. This will work as expected for all primitive data types and strings, but not for any other reference types. Also, if you're coming from Java or working with any other language, equal equals doesn't usually check the value of strings in any other language, but it does in C#. So if you ever have to go to learn Java or work in Java, just know that this is a C# specific things when dealing with strings. All the other primitive data types will check equality like normal in most other languages. Next, we have the not equals sign, which is the exclamation point equals sign. This checks equality as well, but the operator wants to know if the value of x and y are not equal. This will work as expected for all primitive operators and strings, but not for any other reference types. Then we have the less than sign. Less than is true if x is less than y. Next, we have the greater than sign. Greater than is true if x is greater than y. We have less than or equals to, which is true if x is less than or equal to y, and greater than or equal to if x is greater than or equal to y. So let's say you're trying to decide if you need to wear a coat to keep warm at night, and that you only get cold if the temperature drops below 65 degrees Fahrenheit, or roughly 18 degrees Celsius. To decide if you'll wear a coat, you'll need to create this expression, so that if the temperature is less than 65 degrees, you'll wear a coat. While you could assign the result of this expression to a variable and then make a decision based on the variable, it's often better to put the expression you are evaluating directly into the if statement so that it's easier to read the next time you look at it. While many decisions can be made using a single Boolean expression, you may find that you need to evaluate on multiple Boolean expressions in order to make a decision. For those scenarios, we'll use a logical operator. Now, C# has three main logical operators, and let's take a look at them. The exclamation point means not. Basically, this just negates the result of a Boolean expression. So if it was true, it is now false. The double ampersand is a conditional and. This checks that both the x and the y are true. And then the double pipeline is a conditional or. This checks that either x or y are true. Now, both and or are short-circuiting statements, meaning that if we have the expression x and x is false, the whole combined expression is false and y will not be evaluated. And if we have the expression x or y and x is true, then the whole combined expression is true and y will not be evaluated. Now you can also group Boolean expressions together by using parentheses. This may not do anything for the computer, but if you have a lot of Boolean expressions that will determine the final result of some if statement, grouping them can be really helpful when reading that expression later on. Now let's say whether you're trying to decide whether or not you're going to have children, which I know is a huge decision in this world right now and kind of relevant for my life, but let's say that you wanted to give your kids the best shot at life. You may boil the decision down to this if statement. You can see that I have two statements here. The first is that if I'm between the right age and I can afford to live in my area. The second is if my age is less than 35 and I'm ready to have kids and I can afford a tiny human. If either of these expressions evaluate to true, then I would have kids. Unfortunately for me, the conditions have not aligned yet, but at least I could use this to show the compound operators. Now that you know the operators, let's talk about the final piece about how if statements work. If statements allow you to branch the flow of control of your application to execute some code and skip other code based on the Boolean expression you provide. So while an if statement allows you to execute some code while the expression is true, you can add an else statement to the if statement, which will allow you to execute some code if the expression is false. Take this example. If it's cold outside can be determined by if the current temperature is less than or equal to 62 degrees Fahrenheit. If it's cold outside, then I'll wear pants and a coat. But if the temperature is greater than 62 degrees, then I can wear shorts and flip-flops. What I wear will be determined by the Boolean expression, and only one of these blocks of code will be executed. Taking this a step further, let's ask ourselves, what if we need to do many different things based on the same value? Something like assigning a letter grade to a variable. I could use a bunch of if statements like this example, but this won't quite work. Take a minute to pause the video, read the code, and determine what the value of the letter grade variable will be at the end of this code. Did you pause and make a guess? If you guessed that letter grade would equal F, then you guessed correctly. The reason for this is that when you write if statements like this, each if statement will be evaluated, which in this case means that each if statement is true, meaning that each statement sets the letter grade to the next letter down, and the final result is F. However, if we write those statements as an if-else chain, then the first if statement that evaluates to true will be executed and the remainder will be skipped. Knowing that information, what do you think the outcome is for this example? If you said A-, then you'd be correct. The reason is that this grade is not greater than 98 or 93, so both the first and the second if statements are false. However, grade is equal to 89.5, so the letter grade gets set equal to A-, and then the rest of the if-else chain is skipped. So now that you know all there is to know about the if statements, let's return to the code. Now taking a look at our code, if answer doesn't equal capital Y and it doesn't equal lowercase y, then we want to ask them the question again to ensure that the name is recorded correctly. Once we have their name correct, then we can issue a formal greeting under that name, and at this point we could ask the user for more information. All right, y'all, thanks for watching. You have learned a lot of information and we've done a ton of stuff. So at this point, you should have a solid understanding of how to work in Visual Studio, how to interact with the user via the console, how to create variables, and how to have your program make decisions. So that is a ton of information for a single video. Give yourself a pat on the back because you have absolutely earned it. But let me pose you a hypothetical question. What if at this point in our code, the user messed up their name a second time? So they input their name the first time, they don't like it, so they say, I want to change it. They go through that code to change it again, but then they don't like what they entered the second time. How would we get them to do it again? Well, you can't really copy and paste again, because that would be problematic. But in the next video, we'll refactor this code and introduce you to the concept of loops, which will allow you to write a little less code and have the user be able to continue to input their name until they are satisfied with it. So if you want to wait for that next video, go ahead and subscribe and ring the bell to be notified when I drop the next video. But if you're watching this long after the series has come out, you can click on the video thumbnail here or the playlist here to take you to either the next video or the entire playlist for this series respectively. Alright guys, I'm Sir Pinkbeard, thanks for watching, and I will see y'all in the next one.